Hello and welcome to SGN Tech Forum. This is AWS Crash Course. So far you have seen compute, you have seen storage, and now we are taking a step forward and dwelling into some advanced topic, which is the promise of cloud, right? The elasticity. So we will be looking at AWS load balancers, and then we will touch base upon auto scaling group, and after that we will go into demo where we will build a solution that is really scalable. All right, so let's look at the load balancer first, right? And as you can see, there are a couple of varieties of load balancers or variants of load balancers, and we will talk about all of them here. So let's go to the next slides. What we have in agenda: introduction to AWS load balancers, three different type of load balancers: elastic load balancers, network load balancer, application load balancers. We'll discuss when you would like to use one versus another. Then we'll go to conclusion. All right. So this is the definition of AWS load balancers. Load balancer, as it mentioned, as the name suggests, right? It helps you balance the load. That means the incoming traffic coming to your services or to your server, right? How you can balance that load which is incoming. So there are three type of load balancers: elastic load balancer, network load balancer, and application load balancer. Each type of load balancer is designed to meet specific requirement and use cases. Load balancers distribute incoming traffic across multiple servers, helping to improve application performance, availability, and scalability. So those are the three things, right? It help you improve application performance. It help you improve application availability. That means behind the scene, if some of the servers are down, the application is still available. And scalability, that means when you point in time when you have huge load or variance of load, you can scale. They also provide fault tolerance by automatically routing traffic to healthy instance in the event of server failure. So that means intelligently you can check your server health and make sure that your incoming traffic is hitting a healthy server, right? So that help you with fault tolerance as well. This is the screenshot from AWS itself. It talk about three different type of load balancers. As name suggests, application load balancers looking at the application layer, in this case HTTP or HTTPS. And here you can see the definition, right? Choose an application load balancer when you need a flexible feature set for your web application with HTTP or HTTPS traffic. So there is some application which is listening on HTTP or HTTPS, and you want to have all those benefit of load balancer, then this is the preferably the right choice for you. Operating at the request level, application load balancer provide advanced routing and visibility feature targeted at application architecture, including microservices and container. So this is the application load balancer you can also use with an application which is say container based or have microservice implementation versus network load balancer. Network load balancer is not a new thing, right? If you are a network engineer, you must have heard of Citrix load balancers. They're really popular. F5 is another load balancer. So what is a network load balancer? Network load balancer, as the name suggests, it works at IP TCP layer, right? Layer 4. Choose a network load balancer when you need ultra high performance, TLS offloading at scale, centralized certificate deployment, support for UDP, and static IP address for your application. Operating at connection level, network load balancers are capable of handling millions of requests per second securely while maintaining ultra low latency. So, as you can imagine, this is this works at the network layer, and it's not survey. If behind this there may not be like a server which is serving the application directly, but it is in network path, right? So during those cases, also TLS termination and offloading is a key component or use case when you would like to use network load balancer. Then finally we have the gateway load balancer, and this is pretty much specific to the cloud. Choose a gateway load balancer when you need to deploy and manage a fleet of third-party virtual appliances that support Genevieve. These appliances enable you to improve security compliance and application policy control. I haven't used this much. So I think this is cloud specific, and as you can see, it it works at IP level, right? Purely IP level, layer 3, versus network load balancer, which is at layer 4, and application layer load balancers, which works at layer 7. All right, now let's look at each one by one. Elastic load balancer is basic load balancer that distribute traffic across multiple EC2 instance. Now we are talking about specific AWS specific implementation. And one of the load balancer, what is in offer is ELB, or Elastic Load Balancer. It is a primary type of load balancer that distribute traffic across multiple EC2 instance within a single availability zone or multiple availability zone. So load balancers, they are sitting at region level, and behind that you can have EC2 instances sitting in multiple availability zone. ELB is designed for applications that require simple load balancing without advanced routing or traffic management feature. ELB support HTTP, HTTPS, TCP, SSL protocol, and can be configured for health check to monitor status of target instance. It also integrates with auto scaling to automatically adjust the capacity based on traffic demand. So as you can see, this is really versatile, and most of the time if you are using infrastructure as a service, you will be using ELB. So as you can see, ELB is very versatile. It can look at layer 7. It can have a lookup or rule based on layer 7. It can also do layer 4, like TCP, TLS, offloading everything. And also it provide you health check capability, and it integrate nicely with auto scaling, which is kind of like a concept, not a technology, and we will talk about that in our next video. Then we have network load balancing, classic networking load balancer, right, which is working at cloud, is a high performance load balancer that operate at the network layer and is designed for applications that require ultra low latency and high throughput. So the throughput and low latency, that is the key thing. You really want have high throughput and low latency, and don't want to waste time looking at upper layer protocol. NLB is ideal for TCP UDP based traffic such as gaming, streaming, and real-time communication applications. NLB also support static IP address, TLS termination, cross-zone load balancing. It also provides connection draining to ensure that in-flight requests are completed before terminating unhealthy instances. So it's also very versatile. The only catch is it works at layer 4. Uh, some application they require a static IP address as a target destination, and if your application need that, then probably network load balancing is one of your option. Again, it is a uh, region specific, so you can have cross zone, and also unhealthy instance check and make sure that in-flight requests are fulfilled before terminating an unhealthy instance. So you want to make sure that nothing is getting black hole. So those things or those capabilities are inbuilt. Application load balancer. The application load balancer is a feature-rich load balancer that operates at the application layer and is designed for modern web application that require advanced routing, traffic management, security feature. ALB is ideal for microservice architecture, right? So you can very well serve your application using ELB, but in case you have Kubernetes or Docker containerized application, you would like to implement ALB. ALB support content-based routing, path-based routing, host-based routing, URL rewrite, and it integrate authentication and authorization using Amazon Cognito or Open Standard OAuth 2.0. It can also offload SSL and TLS, just like network load balancers. You can bring your own TLS certificate or use AWS key management store to and get the certificate. Updating the cert at one ALB, update to all other automatically. So that is a key, I think, benefit for using ALB. Now, so we know what is ELB, NLB, and ALB, and we already discussed upon some of the use cases, but let's look at them quickly one more time. ELB is suitable for simple applications that require basic load balancing. like small website development or test environment. NLB is suitable for application that require ultra low latency and high throughput. ALB is for modern web application like containerized applications. Now, when you adopt the cloud, always one thing you have to keep in mind is a cost, right? Because this is pay as you go model. You don't pay for your devices or your applications upfront. So it's always whatever solution you are rolling out, you have to make sure that you are aware of the cost component. So let's look at what does it cost for application load balancer and other. So for application load balancer, you are charged for each hour or partial hour that application load balancer is running, and the number of load balancer capacity unit LCU used per hour. So how much or how many hours your ALB is running, as well as how many LCU it is serving. Now for network load balancer, pretty much same thing. You will be charged how many hours the services are up and how many NLCU this load balancer is serving. Gateway is also pretty much same. You can read through it. And then there is another variant of classical load balancer, which is kind of like a phase out. You can think of it as similar to elastic load balancer. You are charged for each hour or partial hour that the classical load balancer is running, and for each GB of data transformed through the load balancer, right? So uh, incoming request served by classical load balancers and outgoing request, they'll be cumulatively charged, but this is not in use anymore. Then for if you are a free tier customer, that means you are hobbyist, you are trying or using that AWS free tier to follow up this SDN bootcamp, what you will be charged. Get started with ELB for free with AWS free tier. Upon sign up, new AWS customer receives 750 hours per month share between classical and application load balancers, 15 GB of data processing for classic load balancer, and 15 LCU for application load balancer. So basically, just like EC2 instances, you get 750 hours of free uptime and you get certain quantity of LCUs. So it's free to use, feel free, go ahead, but make sure that you are aware of what is the free tier quota and set up some alarms. This is the link for pricing. You can check further. Now the conclusion is, we know what are the three different load balancers, but this picture here, I'm showing you one ELB, and everything what we discuss, we are going to summarize it here. As you can see, there is a user who's accessing some services which is running on target group. Think of it as a server, and there are that application, say a website, is distributed or running on all those servers. When a user try to access that, it actually uses internet and landing to elastic load balancer IP address or a DNS name, FQDN name, which can be aliases to your application or web service. So say if you have www.example.com, you can alias that to your elastic load balancer FQDN. Elastic load balancer FQDN will be a AWS a specific one, a long string. You can alias it to your website, and user in turn will use access the website. The website will first go to elastic load balancer, where this elastic load balancer is listening on a rule set, say in this case HTTPS, which is TCP port 443. Based on that, it has target groups like servers running in different AZs. They are combined as a target group, and based on what kind of rule you define on your ELB, it will forward the incoming request to your target group. You may say round robin. That means when the first request comes, send to AZ1, then the second request comes, send to AZ2. So like that, we are going to build this ELB in our demo, right? So while reducing the risk of downtime, and as you can see, even if some of the servers from my target group is go down, ELB can run a health check and make sure that it doesn't forward any incoming traffic to the faulty server. Those checks are inbuilt. And now we will talk about ASG. Once we understand auto scaling group, we will tie ELB, load balancer concept and auto scaling concept together and create a demo. Thank you for watching.